Hello everyone, my name is Lena, I'm a PhD in mathematics and this is my blog about mathematics around us. I'm from Russia and I'm afraid my English is not very well, but I promise if you still listen, it will be interesting. Yet perhaps what will be discussed has some Russian specifics. So it's definitely will be clear to the people from the USSR, but whether it be clear to the people that never lived in the USSR, it is not known. Well, let's try to find out. And write please in the comments what you think about it. If we flip the coin, the Russian coin, and it comes up tails 9 times in a row, what are the chances that it will come up tails again on the 10th time? Very, very small? Not. Is equal to 50%. This is one of the paradoxes of probability theory. It seems to us that some event has a very small probability, but in reality it is not true. When we have already tossed the coin 9 times and got the result, then we can have 2 further results, heads or tails. Each has a 50% probability, because the results of the attempts that we already made do not affect the results of the 10th attempt. Another thing is when we are just about to toss a coin and try to estimate a probability that all 10 attempts will give us tails. This probability, of course, is small, is equal to 0.5 in 10th power. However, it will be equal to the probability of ordinary chain. But this is just a cognitive distortion, not the real probability paradox, and there are real miracles. Now I'll tell about it. Let's go.
Liftoff of the Delta rocket carrying Blast.
This is where the real mystery begins. Let's we have a group of 10 students and they have to take an exam. There are in total 10 exam questions that are on 10 different papers. It is important that all students must pass the exam. For example, because they decided to go on a trip after the exams and cannot stay for a retake. At the same time, the exam is already tomorrow, and each of them have time to learn only one question. This situation is absolutely normal for the country that used to be part of the USSR. And how it for you? It is very interesting. Please write it in the comments. Suppose the teacher is very well and he allowed to change the paper with the question for 5 times. However, at the same time, he is not a supporter of freebies. And after the student has taken the paper with a question, doesn't want to change it, the teacher puts the same paper in place of the collector's paper. It is easy to see that even in this scenario, that the probability that each student will be able to find his question is equal to 0.5 in 10th power. It is very, very small. That is 1/1000th. One might say that is hopeless. It turns out that the idea is guaranteed to fail? Imagine, no, there is an algorithm that allows to improve the probability that all the students pass the exam up to 36%. And this is without the teacher's hypnosis session during the exam, or urgent courses, offer to the use of cheat sheets and so on. And if we also have a course leader who not take the exam but can enter the classroom before the exam and in a special way change only 2 papers with the questions in places, and it's all, not telling anybody anything, then the probability that all students pass the exam will be equal to 100%. 100%. How is it possible? Let the students have divided 10 questions among themselves and they go to pull them in turn. The papers are in row. We don't know, of course, which one is which, but we can numerate it by order. After the student has pulled the paper with the question that he knows, the teacher puts the same paper with the same questions in his place. A student who has learned, for example, 5 question draws the paper that is in 5th place. What is the probability to draw one he knows? Small, in fact, only 1/10. Suppose he has taken the question of what he doesn't know. For example, question number 7. Then he puts the paper in the place and draws the paper that is in 7th place. So he continues until he finds the question that he knows or the number of attempts is complete. Suppose the student found his question, the teacher put the same paper in the place of the paper he took, and the new student entered the classroom. He began to pull the papers according to the same algorithm, starting from the number of paper that was equal to the number of questions that he knew. So what, you ask? How will this help students pass the exam if they know only one question? As always, with the help of ordinary magic. In fact, we have replaced random enumeration with enumeration of permutations, sequences of numbers. By following this algorithm, starting from the number of questions he has learned, each student is guaranteed to be in the sequence of questions, ending with the number of questions that he knows. For example, questions can be arranged in such a way that they form the following sequence. This means that in 9th place is question number 4, in 4th place is question number 5, in 5th place is question number 3, in 3rd place is question number 9, the following sequence: in 2nd place is question number 1, on the 1st question number 7, on the 7th question number 2, and the next sequence. In the 8th place is question number 6, in the 6th place question number 8, and on the 10th place is exactly the 10th question. It is clear that the success of students' strategy depends only on whether the sequence he got into is longer than 5 questions. That is, will there be any like this? It can be seen here that the first cycle has a length of 6, and the student who has learned the first question is unlucky. He will pull out his question only on the 6th attempt, which will not be. But if the head of the course intervened in the process and changed 2 papers, for example, the one that is in 6th place and in 5th place, that is, it turns out like this. Then the group is saved. Everyone will pull out their question with a probability of 100%. Not just in 5, but even in 3 attempts. Intuitively, the operation of the algorithm I think absolutely clear, since there can be only 1 second longer than 5 for 10 questions. And the course leader can always split it into 2 by swapping 2 papers. It remains to understand where the probability of a positive outcome is about 30% if the exam is held without a course leader. Here we need some information from combinatorics, but I will try to use only very simple things. Permutation of numbers from 1 to 10 can contain no more than 1 cycle of length L more than 5. There are so many ways to choose numbers for such a cycle. These numbers can be arranged in a cycle L minus 1 factorial ways, since due to cyclic symmetry, there are L ways to write the same cycle of length L. The remaining numbers can be arranged 10 minus L factorial ways. Total, the number of permutations of number from 1 to 10 with a cycle of length L more than 5 equals 2. The probability that a uniformly distributed random permutation does not contain a cycle longer than 5 is calculated as. For those who studied in countries that used to be a part of the USSR, it is more normal if the teacher allows the student to change the paper with a question 3 times and not 5. Do students have a chance to pass the exam on the same algorithm in this case? In general, the chain length distribution function looks like this. From this, we can estimate that all students following this algorithm will be able to pass the exam in this case. It will drop sharply and will be about 4.46%, which of course is still much more than 1,000. However, if the head of the course can still come to the classroom before the exam and now change 2 or 4 papers in places, he needs to get rid of cycles longer than 3, and there may already be not 3 but 2. Then the probability of passing the exam for all students will again be equal to 100%. The same principle works with a larger number of questions. In general, this is known as the paradox of 100 prisoners and 100 boxes. Each of the 100 prisoners has a number, and this number are randomly placed in 100 boxes. Prisoners must, one by one, pull out their numbers from the box in 50 attempts. All prisoners are executed if at least one does not pull out his number from the box, and everyone will be released if everyone pulls out his number. They can communicate only before the 7th and do not communicate during this process. You know how they need to act in order to survive and go free with a probability of about 30%. Moreover, if the number of prisoners, questions, was very given, then the probability that following such an algorithm it will be possible to achieve success is as follows. So it means the probability is about 30%. In 2006, proved the optimality of this method. That is, there are no better ways to solve such a problem. Thank you for watching to the end. Like, subscribe, and please write in the comments what was clear, what not clear, how is my English for you, and what it will be interesting to talk about. See you soon!